So in this video we're going to revisit sums, products and addition of ordinates for functions. So we know that x, y in the brackets like this we call coordinates or a coordinate pair. For addition of ordinates, what we're doing is for each x value, we look at the y ordinate for that particular point on the function, and then we either add them, subtract them or multiply them. And what that does is gives us a new y ordinate for the new graph. And what we do is we focus on one x value at a time. And one of the easiest things to do is to use the easy to recognize points. So our x-intercepts, our intersection points. And remember that we can only add ordinates where both functions exist. So let's have a look at what we get when we add ordinates for our exponential, log and trig functions. We get some very interesting graphs. So let's very quickly just do a little bit of addition of ordinates for these two graphs. So we have f of x is equal to x and g of x is equal to e to the half x. So to add the ordinates together, we'll start at x is equal to 0. So on the green graph, our ordinate value, our y value here is 0. And for the blue graph, our y value is 1. And if we were to do f of x plus g of x, we would add those two values together. 0 plus 1 is 1. And so I'm going to put a cross where our new y value will be for that particular x value. And then we'll go across, we'll do another x value. So let's do x is equal to 1. When x is equal to 1, on our green line, we've got a value of 1. And for our blue line, we've got a value of about 1.7. 1.7. And so if we're going to add them together, 1 plus 1.7 is 2.7. So we're going to end up with a y value that's about there. And then we do the same for x is equal to 2. And so we get x is 2 and the y is 2 and 2.7. So our new value is 2 plus 2.7 is 4.7. And then put a cross and join the dot. Now you can see, oops, I've missed it. So now what I'm going to do is I'm going to go back and I'm going to rub out that line and fix it up. And so in the exam, you need to be able to do this as well. So in the exam, if you're asked to draw a graph, use a pencil so that you can fix it up. So if we continued our addition of ordinates out this way, let's look at x is equal to minus 1. And so we have minus 1 for the y value plus 0.6 gives you minus 0.4. So we'll put a cross at minus 0.4 there. Then we'll go across and we'll do minus 2. So when x is equal to minus 2, we've got y is minus 2 here, y is 0.4. So add those together and you get minus 1.6. And so we put a cross here and we will continue our graph down that way. So let's do addition of ordinates on the two functions we've got here, a sine curve and an exponential graph. So what I'm going to do is I'm going to identify the key points, which will be where the graphs intersect and any x intercepts we have. So the function that we're going to create is an addition of these two graphs. So we're going to take the y values for this particular x value and add them together. And because it's where they cross, we're going to add twice this y value together. So along this x value here, it's going to be twice as high. Then where the x-intercept is, the y value at this point here is 0. So 0 plus whatever the y value for this point is will just be that particular value. So we'll put a red cross here. We can do the same at this x-intercept as well. So the y value is 0. The y value straight above it is 1. 0 plus 1 is 1. So we'll put a red cross here. For this x-intercept, it's 0 There's its y value, put a red cross, and so on and so on. And then go back and do the same process for x values in between those points. Like here, and then something here, maybe something here, and so on and so on. And then we'll join the crosses. You get some very interesting graphs when you sketch addition of ordinates for trig graphs and with exponential graphs. So there's our sine curve, there's our e to the half of x, and there's the addition graph that we just created. And you can see that it's kind of cyclical. There's the subtraction graph, so that is f of x minus g of x, that's f of x minus g of x. You can see there's some similarities in the patterns. There's the two original graphs again. And this is just the subtraction done differently. So this one here is g of x minus f of x. This is f of x minus g of x. You'll notice that they're actually mirror images of each other. And this finally, this last one, is the product function, where it's sine of 3x e to the x. And you can see that it's a very interesting function, and that it's oscillating and it is increasing in an exponential shape this way and an inverted exponential that way. So this is the same idea, this time with a sine graph and a log graph. And so the function is only going to be defined. This is the addition function, the red one that's just come in, and it's only defined where the log graph is defined. And you can see that it's got an asymptote just like the log graph. And so this is f of x, this is sine of x, sine of 3x minus the log graph. Again, you can still see it's still got the asymptote where the asymptote was for the log. And here we go, we're going to do, this is g of x, g minus f, and this is f minus g. Can you see that they're mirror images of each other along the x-axis? Which is what you would expect. And this is our product function. This is sine of 3x times log of x. And you can see that it's increasing, but it's not exponential along the top now. Now that increase is guided by the actual shape of the log graph itself. This one is a tan graph and a log graph. And so we've got asymptotes and a restricted domain. And so you can see that it's still asymptoting. That was the addition graph. This is the subtraction graph, and you can see that it still has asymptotes where the asymptotes were for tan. So this is tan minus log, and there's the log graph again. And now we'll look at log to the base e of x minus tan. So let's just wait a sec. There it is there. So this is log e of x minus tan of 3 of x, and you can see the position of the vertical asymptotes. You can see it asymptoting here. These are the two subtractions that are mirrored images of each other again. So one's f of x minus g of x, the other one is g of x minus f of x. I'm just going to change up the colour on one of them so that it's easier to see. There we go. So now you can clearly see the difference between the two. So exam questions for addition of ordinates are often multiple choice questions. So they'll give you the shape of the two graphs and ask you to add them or subtract them or multiply them. My suggestion is if it's multiple choice, you've got your CAS, and generally you can create some kind of model function. So it might be recognised that the first one's kind of exponential, the other one's kind of a circular function. Put those two together and make a model, see what it kind of looks like. If you are asked to draw one, use pencil. Okay, any graph, use pencil. If you stuff it up with pencil, you can rub it out. And if you're drawing a graph, you'll have marks for shape, end points and crossing particular points on the grid. And if you do it in pen and you stuff it up, it's very hard for the person marking to see that you've actually hit that correct point, that the shape is nice and smooth. If you do it in pen and you make a mistake, immediately you get this hairy shaped hybrid function where you've tried to fix it. Use a pencil. The other thing you need to watch out for, a common question around addition of ordinates, is an idea of dosing with medicine. So you'll know that you might have some tablets, paracetamol tablets at noon, you can have some more at 4 o'clock, and they're the sorts of questions where you start to have an addition of ordinates questions. Let's have a look at one from a past exam paper. So this question is taken from an exam paper. And you can see that we've got an amount of drugs here. This is tablet 1, and this is the profile of the amount of drug in the tested fluid, okay, the amount of blood in the bloodstream from tablet number 1. So it's had at, let's say it's had at noon, and then 6 hours later they have another dose of the tablet, and so that tablet dissolves into the bloodstream and the concentration of the drug goes up and then comes back down. But you can see that at this point here at 6 hours, there is still some of the first tablet dissolved into the bloodstream. And so the question asks below, on the graph above, sketch the total amount of drug in the bloodstream during the first 12 hours after tablet 1 is consumed. So we're going to do an addition of ordinates, and so we are looking at our value for the first tablet right down to where the second tablet is consumed, because that's all that's in there. As soon as you take the second tablet, this green graph now needs to be added to that red graph, and so your total graph needs to spike up here, because at 6.5 hours you've got the same amount of drug from the first tablet as you have from the second tablet, so you will have twice as much drug in your system from there. So we're looking at it being up here somewhere. And you can see already that I need to go back and tidy that up with my pencil. And so we need to continue adding those particular things, and the only way to do this is to choose a particular point. Like 8 hours looks like it's going to be where the maximum is, so we're going to take this value here, which is 1 and a bit squares, and we're going to add that onto 1 and a bit squares up here, and so our graph is going to come up and to peak in here and then run back down. Check again further along and add that on there, and make sure that you are running your line roughly through where it's meant to go. And so as an exam question, points that the examiners would be looking for to see, do you know how to do addition of ordinates, will be these points. The point where the second drug starts to become dissolved. So the examiners would be looking for some kind of change at this point here. A common mistake would have been to start the curve from this point here where they intersect. The other key point that shows addition of ordinates is this is the maximum of the second one. And so for our combined curve, it should have its maximum up in here somewhere as well. And then as it tapers off across here, just generally checking that at the end of the graph here, that this amount here is added onto here, so that the line is coming down within this region somewhere. So they're the key points that you need to be watching for. And finally, I want to show you some graphs of combined sine and cos functions. So there's your sine function, there's your cos function. So if I add the two functions together, I get that red graph. And you can see it's still cyclical. There it is there. And if I then look at the subtracted graph, it's cyclical as well, and it kind of looks like the addition graph. Okay, there's the g of x minus f of x, so that's the opposite subtraction, so there it is there, and that is the comparison of the two. So f of x minus g of x is red, and g of x minus f of x is yellow. And again, you get that reflected pattern, reflected across the line y equals 0 along across the x-axis. And there is the product function, sine of x times cos of x. And you can see that it's smaller than the original sine graph and the original cos graph because you're multiplying the values together. And both of the values for sine and cos have a maximum of 1 and a minimum of -1. And so when you're multiplying fractions together, you'll get a smaller value. And hence the y values for the multiplied function are smaller. And finally, let's look at combining a linear function and a trig function. So there you've got sine of x, and the blue line is y is equal to x. And if we look at their product function, you can see that you get the oscillating pattern, and last time it filled out to, with the oscillation when you multiplied it, it filled out to create an exponential shape or a log shape. This time it filled out to create a straight line shape. So this is g of x, so this is x minus sine of x, and that is sine of x minus x, and it's kind of a little wiggly line. And this is what you get when you add the two together. So you can get some really interesting combinations of shapes that are combining to give you some very interesting shapes. And some of the ones that I have shown you have been used in past exams.